Edexcel, Core Pure, Sequences in Series 3, Method of Differences and the Maclaurin series of composite functions. We've already seen how we can find various Maclaurin series for these standard functions below. These standard functions below could be combined to find polynomial approximations for various composite functions. So for example, if we were looking for the cubic approximation for e to the x cos 2x, now we could take f of x equals e to the x cos 2x and work out various derivatives of this function in order to produce a Maclaurin series formula. However, this would involve quite lengthy use of the product rule. It would be much quicker and easier to make use of the two standard expansions for e to the x and cos x. So if we wanted a cubic approximation for e to the x cos 2x, we could do it as e to the standard polynomial approximation for e to the x times that of cos 2x. So the cubic approximation for e to the x can be quoted as 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and multiplying it by the result for cos 2x. We need to be careful with this one because it is cos 2x and not cos x, but we would get 1 minus 2x squared over 2 factorial, and I don't need to do the quartic term because we only want a cubic approximation. So tidying up each of these Maclaurin series, we get 1 plus x squared over 2 plus x cubed over 6, and for this one we get 1 minus 2x squared. So multiply them together, expanding the brackets and collecting like terms, we're going to get 1, we're going to get a single x, we're going to get a half minus 2 x squared terms, and we're going to get a sixth minus 2 x cubed terms, and therefore my Maclaurin approximation for e to the x cos 2x is 1 plus x minus 3 over 2 x squared minus 11 over 6 x cubed, and there is my cubic approximation. As we can see the full work in there. So that brings us to the end of method of differences and the Maclaurin series.